Hi, everybody. Hi, sir. This is Zainab Bamba, and I'm here to do my presentation on that topic, which is digital forensics practices and methodology for AI speaker ecosystem. Okay. Before getting to the introduction, I'm gonna say that in general, AI speakers are Internet of Things devices. AI speakers are being released now with different functions to improve user convenience and better life. Because, like, as you can see, those new Alexa devices makes your life easier. You can be sitting and then tell Alexa to do anything, turn off the light, turn on the TV, play music, you name it. So my project is gonna be based on that AI speaker and its functionalities. What can he do in the forensics digital analysis live and so on. So by definition, we can say that an AI speaker ecosystem is a cloud-based Internet of Things system, which is built around a AI, which is built around a AI speaker and an Internet of Things devices. An AI speaker can be used to provide vital evidence of digital forensics. However, privacy issue may raise. Um, Using those AI devices can be can be helpful for people, for end users, that is for sure. But we have uh, security problem because like anybody can access those speaker because they're accessible to everybody. So in my presentation, I'll propose 5 digital forensics analysis methods for 4 AI speaker model from different manufacturers. These 5 proposed methods are applied to all AI speaker models. So that means whatever you call AI speaker, they have a basics functionality. So they, which is common to all of the AI speakers. So I'm going to go briefly and I'm going to go briefly about those AI speakers and their functionality. I don't have enough time to go through everything, but I'll do my best to explain most of the things. So as an introduction, I can say that an AI speaker is a user-friendly convergent ecosystem that was created by combining Internet of Things and cloud computing. The AI speaker ecosystem operates based on the cloud and provides question and answer services through an AI-enabled speaker ecosystem. Unlike general Internet of Things devices, an AI speaker plays a pivotal role as a system that controls various Internet of Things devices, which is incorporated with mobile devices. So when you take Alexa, I like talking about Alexa or Google because these are the known devices, AI speakers. So when you take your Alexa, you have the the Alexa app on your phone and you can direct everything on your phone. So Alexa can have access to your data. Okay. I'm gonna concentrate a little bit on those question and answer function and the control over the Internet of Things products, which are some eye points digital devices, which and those, I mean, those devices are really important for our our digital forensics materials. Although the AI speaker ecosystem has just been released, there are already a number of cases which required digital forensics investigations. So by that, in my article, they talk about a crime which was committed in Arkansas. In that crime, that person had Alexa in his house, and when they came to analyze the scene, they saw Alexa, and they automatically took Alexa as a proof, and they were able to get information from that Alexa. So the Alexa was really important in our digital forensics. I mean, in their digital forensics analysis. However, AI speaker cannot provide the location, even though they store a lot of data based on the cloud and packets encrypted with TLC-based communication conceal data. So Alexa can have a lot of data. Alexa can provide a lot of data, but which Alexa cannot provide or the location. Where did the crime happen? When? At what time? We cannot have those information from Alexa. So here in my presentation, I'll be talking about a performed digital forensics analysis of 4 AI speaker model from major internet portal, which is Naver and Kakao, and mobile communication company majors, which are SKT and KT. Those are being commercialized in the public of Korea since the AI speaker industry is growing. So the four major commercialized speaker in Korea, the Naver, the KKO, and the SKT and KT. My paper will have section. The first section will describe digital forensics techniques related to existing digital forensic studies on similar platforms. And the second section will be about explaining digital forensics techniques related to the proposed analysis and methods. So here is the 4 points of the forensics analysis of an AI speaker ecosystem. The first one is the packet analysis via AI speaker. The second one is a packet analysis via Android mobile app. The third one is Android directory analysis. And the fourth one is APK, the compilation analysis. The fifth one is AI speaker chip of analysis. So those are the forensics analysis of a AI speaker ecosystem. I'll go through them now one by one. So here is the AI speaker ecosystem analysis components. As you can see on the left image, it shows an I mean let me see an image of what it virtually looks like, and on the right side you can see the actual devices, and they are in different compartments because like there are different compartments, but they're all linked together. So forensic analysis of AI speaker ecosystem will go first of all through the AI speaker ecosystem, which is a classified Internet of Things system and operates in conjunction with various Internet of Things devices and services. However, AI speakers have major components that are controlled to the Internet of Things. With an AI speaker or mobile application as its center, this system can be linked to most internet-based services. Although those speakers store and communicate various data that can be useful for digital forensics, such as personal information. As I was saying about Alexa, Alexa has like all our data. Like Alexa has all information about us. Alexa knows our name. I mean, everything that is personal because we use our phone and we have everything in our phone. There's also the cloud storage information and the user whereabouts. Alexa can provide all those information. So this picture describes the major component constituting an AI speaker ecosystem. On the right image, this image can be divided into a network forensics that are mobile forensics area and AI speaker forensics area. So this image as the first part, which is the network forensics. The second part, which is the mobile forensics area, which is on the left. Then the right side is the AI speaker forensics area. So here's the packet analysis via AI speaker. This packet analyzes the communication process between an AI speaker and the cloud, which corresponds to the network forensics area. This package are sent from the AI speaker to the cloud via an access point. As you can see here, you see the cloud, and it is sent from the AI. Here's the AI. I mean, I don't know if you can see. Let me move. So here's the cloud, and then you have the Internet of Things application. So those are the actual devices, and then you have the network forensics area right here. And I think that is pretty much all. So this one represents the ecosystem of an AI speaker. And we have the packet analysis via Android mobile applications. So this one is used to analyze communication between an application and the cloud, which correspond to the network forensics area. So here you can see the the network forensics area. So here's where the the Android mobile app comes from. As you can see, it's right here, Android mobile app. So here, in this package, packets sent from Android mobile app um, has access to the cloud, has access went to the cloud. So they're all linked. And, this image gives more details about what I'm talking about. As you can see, here's the cloud data, and the cloud data communicate with the registered Internet of Things device, which has a lot of application inside, and those providers and whatever it needs for the device to be working. And here's the actual device. So that is, I'm sorry. And we have the Android directory analysis. This Android directory analysis correspond to the mobile forensics area. For Android directories analysis, data stored in a smartphone is collected and analyzed using the Android smartphone, which is collected and analyzed. Yes, and this Android directory analysis allow us to communicate with the cloud while using applications such as AI speaker configuration and voice commands. As I was saying about Alexa, you just use your voice and Alexa keeps all your information, all the information. So in the process, some of the data are exchanged with the cloud, and uh, some of the data are exchanged with the cloud and the app, and also some directories are also stored and used by the AI speaker. We can have access to the artifacts such as personal information, information on connected speaker, and voice command information can also be obtained by analyzing the Android mobile app, Android mobile directory. Then we have APK decompilation analysis. This analysis corresponds to mobile forensics area. It describes how to obtain artifacts for Android mobile applications. And it also communicates with the cloud to process the user's input, whatever the end users want. We can use the APK decompilation analysis to provide those information. In fact, information sent from the AI speaker and application to the cloud with details is analyzed by the compilating the Android mobile application. Here is another part, which is the AI speaker chip of analysis. This corresponds to the AI speaker forensics area. It is an image-based digital forensics analysis technique. So we can use this technique to analyze an image. So here is, as you can see, some of the techniques are repeating themselves. But here we're going to talk about practicing to collect and analyze artifacts in AI speaker ecosystem. So to go through those analysis. We're gonna start by talking about the packet analysis via AI speaker, Android mobile apps, then go to Android directory analysis, and then talk about APK compilation analysis, and end with AI speaker chip off analysis. So the packet analysis via AI speaker. Okay, the method for collecting and analyzing. Okay, I'm gonna go before coming to this part. I'm gonna go through general things about AI speaker. So that the AI speaker ecosystem can use this method for collecting and analyzing data from an AI speaker and Android app required. And these two required the same analytical technique. Basically, an AI speaker and an Android mobile app use HTTP and HTTPS protocol to communicate with the cloud. The Android mobile app can communicate directly with the cloud, as we saw on the first part of my presentation, and is used to set the communication section between the AI speaker and the cloud through connection and configuration of an AI speaker. And yeah, these two HTTP and HTTPS are protocol for communication within clouds, and exactly like Android mobile apps. How do we collect and analyze artifacts? So first of all, okay. So here, first we're gonna configure an environment for capturing AI speaker. The AI speaker packets, and collect the usage data for AI speaker and an Android mobile app in real life. If setting up a proxy is not possible in this case, we can use Wireshark. What is Wireshark? Some people don't know Wireshark, but Wireshark is an application that is used to collect data from the cloud. It tells us about all the protocols that are being used. So I'm gonna move to the Android directory analysis. Android directory analysis gives us information from configuration files on the user's personal information and cloud communication data that can be stored in the directory of Android mobile app. Android directory analysis collects and analyzes stored data and derive signification information. So like anytime you go, if you need a data or if you need any information, you can go through the Android directories, and those directories are gonna give you all the information that they've stored before. So here, as you can see, there is the APK extractor, which is an application on Android. But to go back to that Android directory analysis, the analysis consists of 3 steps here. The first step is preliminary data collection. The second one is a primary data collection. And the third one is a data collection, the actual data collection. Because like, since those are directories, you have to access the first directory, then have access to files. I'm sorry, then have access to files. So those three steps will drive you to any detail on those directories. So the APK, the compilation analysis, here it consists uh, of a static analysis and dynamic analysis process, which are used for the compilation-based forensic analysis of an Android mobile app. The compilation-based forensic analysis techniques are divided into 6 analysis techniques. The first one is called hierarchy analysis, which is provided by IDE. You just import the decompiled source into a Java IDE. String-based, and the second one is the string-based search analysis, which can be done by using the find function in GADX. I don't know if it's called GADX or GADX, but you just get this analysis done by finding the function in GADX. Depending on the type of artifact, the signature of the retrieval scheme must be changed. So which means that you can retrieve an artifact, but sometimes it can be difficult. So what you have to do, if you cannot use a prox, you just need to change the scheme. And these techniques has the highest efficiency, analytical efficiency. So the third method is the method of reconstruction. I'm not gonna go through everything because I don't have enough time, but we have the method of reconstruction. We have the Dalvik bytecode analysis modification. We have the code line by line inquiring. Yes, and also we have the base dynamic analysis. Okay, so now we're gonna talk about the AI speaker chip of analysis. In this analysis, all the supposed functions based on the user manual are used in order to accumulate all possible data. So here we can go through the file system identification, directory structure analysis, file signature, keywords search, and deleted file recovery. Those are performed after the flash memory containing data are collected as an image or as images. So we just have to have image of the flash memories. And then if we want to have access to all those files, we just have to have an image of the file, I mean of the flash memory, and then collect it as an image or as images. So this is a digital forensics tool for Naver Clover. Naver Clover is a Korean, yes, is a Korean ecosystem. So in this analysis, all the supported functions based on the user manual are used in order to accumulate all possible data. Oh no, yes, I'm sorry. So talking about the Naver Clover, we can say that digital forensics tool for Naver Clover has function to collect comment history, artifact, directory tree, through communication with the cloud without using the Clover mobile app. So this is just an app. This is just an application which is used. It is, we can say that it is, it might be like Alexa or Google, but it's just called Naver Clover. So from here, I will now conclude my presentation by saying that the AI ecosystem is growing up, is growing really fast, because they have started introducing a lot of functionality in those AI speaker, and the ecosystem is gonna be like stronger and stronger for a digital forensics investigation to have more information about all those files, or all the information that can be stored in the AI speaker. So in 2017, after that crime in Arkansas, Alexa was able to give more information 2 years ago about another crime, which was a double crime. And Alexa was able to give all the information, not the location, but the person who committed the crime. The person who was killed tried to call the police from Alexa. So when the police came to that crime scene, they just collected Alexa, and they saw that the person who was murdered tried to call the police. And that was a much better evidence than other evidence. So those AI speakers are gonna get growing in the technology field. So thank you for your attention, and I hope you like my presentation. And I'm really sorry if probably I've been repeating myself on some part. And enjoy. And thank you so much, sir.